So, hi Bella, what was your first computer?
I think it was an Atari. Actually, it was Commodore 64, but that wasn't real. You know, a few print line statements with BASIC, but I think it was an Atari.
Oh, really?
And everybody else had an Apple, but I lacked the money, so I ended up with an Atari.
That is interesting because in my world, the C64 was like the Apple. I had the Spectrum, and there was Atari 800 XL, I think. This was like the entry level, and this was one 520 ST, I think. This was the big one.
Exactly.
Yes.
Everybody else had an Amiga
500.
with color displays, but I didn't like it. And I remember there were wars between the Atari and the Amiga camps. But, I just used it to program Pascal at the time.
Oh, really? So this interests me. So first, why you got the computer, or how you got it?
Oh, I wanted to get it because everybody at the university in Zurich, everybody had an Apple. And because they were too expensive, I got an Atari. And we were taught, I think it was Pascal first up, and then there was another language called Modula 2. Mm-hmm. Later, Modula 3 that was taught at university in Zurich. Mm-hmm. And so Atari had a nice development environment, although it only had 1 megabyte of memory, I guess.
Okay.
You had to flip floppy disks because there were disks for the program, mm-hmm. which was loaded into RAM, and then the data was stored on a separate floppy disk. So that was today you would just have 1 megabyte of memory, okay. But compared to the MS-DOS machines with 640K, that was great.
So it seems like you were older. So you're not. So how old were you then?
Oh, I don't remember.
Because you said. Because you said university, so you got your first computer if you were at university?
No, that was before. It was the C64. But okay. I didn't really program there. It was just a small basic programs. But real serious programming started at university.
Okay, so what interests me, so you got the C64, but you didn't start it immediately programming, right?
Yes.
You did?
Yes, I'm a latecomer. I actually studied computer science and English and minored in psychology.
Oh.
Later, I replaced psychology with economics and made computer science my major.
So you are actually dangerous.
Linguistics background.
Dangerous man. This seems like a spy, you know. The crossover psychology and computers is very dangerous, actually.
Yes. Probably, yes.
Yeah, but what interests me, you got the C64, right? From your parents, I guess. So you started programming immediately, or you just played some game first?
Well, I'm not much of a gamer, contrary to most developers. I told my mother that she needed a computer. Uh-huh. She didn't know why, but I told her she needed to buy one so I could use it.
Okay.
And then I did play some games, but I was mostly interested in doing some basic programming and just getting my hands on this C64.
This is your psychology background, right? How to get your computer?
Yeah, probably.
Okay. And but as a kid, I mean, how you get the idea that you have to program something? You saw a movie, or because. I mean, this is an interesting process. So you are a kid, and now you say, okay, I have to program. So why? How you got the idea? What is the motivation behind?
I don't know. Maybe it was war games.
Okay.
I'm not sure if war games came later or it was before.
Okay.
But computers have always fascinated me, but I wouldn't be someone who says, hey, I started programming at 2 and I'm a genius and blah, blah, blah. No. It all evolved.
Yeah.
I kind of got into it.
Okay. So as what I learned, you started not with 2 rather than with 3, right? Okay.
Yes.
So what was your first Hello World then?
Oh, my first application? It was a address list application. Very stupid.
Okay.
Basically, you could add persons' names. Pascal had the concept of records. and then you could append them to a file, and very basic address list.
And
then you can even print them. I remember at one point, even on the Atari, we were drawing stuff like circles and wanted to print them out. And the printer, an Epson something, pin-based Epson, printed it, distorted it. It was an oval rather than a circle. And so we were actually looking at the hex code that was sent to the printer to try to find out why the printer printed an oval rather than a circle. Mm-hmm. At one point, 4:00 in the morning, my friend called me and found out he told me what the problem was. It was like a wrong control code that was sent to the printer.
Okay.
In hindsight, you would say, oh, this is a waste of time. It's just useless. But you learn stuff this way.
But you were older then. So if you started, with your address application, I assume it was BASIC. Then you switched to Pascal immediately, or you stick with BASIC?
It was actually Pascal. I switched to Pascal very early because it was taught at university.
So it seems like as a kid you started with BASIC, then you just played around, and then the next serious language was Turbo Pascal, right? Or Pascal?
Yes.
Okay. I also tried to write a drawing program, but my problem was to think about how to store the figures, So if you draw something on screen, the idea is how to store it on disk. So this was, I thought a lot about. So, how to do it. So how to store the thing. So I actually forgot what I did. But this is what, printing was too far away. But storing the stuff, this was harder.
Yeah. I guess you didn't use vector graphics.
No.
Maybe just bitmaps.
I don't even remember. But I think I just stored the pixels, which was, of course, too big. But I was also a teenager back then. Right. Cool. So you did some serious work at the university with Pascal. What was the first interesting application you wrote?
The first interesting application, we didn't really write any interesting applications at university. It was mainly, courses. When we switched to Modula 2, there were tasks that were given to us where they had the concept of interfaces and implementations, which I thought was very interesting. Pascal didn't have that. Mm-hmm. And then at the time, at least, and then they gave us the interfaces and we had to write the implementations and bring our code along. And when they actually copied our code onto their systems, the system was supposed to work. That was a good way to see if you failed the test or if you passed it. So it was not really something interesting. It was more or less exercises that we had to do.
Okay.
I guess go ahead.
Question. It seems like this was just, what you had to do at school or at the university. Did you do something in your leisure just for fun?
No. At that time, I was more interested in going out in sports, in playing tennis, and I was not really a geek.
Okay.
Right. Also, I was heavily involved in chess at the time. I played chess after school. I studied openings, all that crap, and it's also a time waste in a way. But it was very interesting at that time because, you can really think about what the next couple of moves are, and it kind of exercises your brain. The problem is because I'm a brain person anyway, you're studying, you're using your brain all the time, and then in your leisure time, you're playing chess. It was getting too much, so I switched. I started playing tennis.
How good were you in chess?
I was not bad. I was almost champion here in my city, my little small town here, 20,000 people. The last match I played, I was matched against my dad, and I said, I'm going to win, of course. So I risked too much, and I lost. Had I only tied, I would have become champion, but I lost, and my father didn't become champion either, but he won. So I placed third, I guess. I was not too bad.
Okay.
But that's a long time ago.
So now you are the champion, right?
No.
I gave up.
Yes.
Yeah, okay. So it seems like you enjoyed, your university time. So what happens afterwards? So when you started, when you really enjoyed programming, you started to enjoy programming in some point of time, I guess, right?
Yes, I during there's like a base the first couple of years in university, it's more or less, it's not very interesting, and then then there's a big exam, and then the second part, there are seminars and stuff, and you have to spend less time at university and work more from home to prepare for seminars or for exams or whatever. During that time, I started working at IBM as a part-time coder, programmer, whatever you want to call it. And that's when I picked up C. They sent me to a C course, and I was like, what the heck is this language? Coming from Modula 2 or Modula 3 later, switching to C was like a big step down or backwards for me. But I learned C, and I worked at IBM part-time. There I started writing programs for them, parsing data from mainframes and displaying them in a nice way, and accessing mainframes through old APIs. Nobody knows about them anymore. And that's where I actually started getting interested in systems programming. So after I finished my my diploma thesis at university, I started a PhD and got into systems programming. Not really systems programming, like not writing device drivers or stuff, but deep down into the bowels of the system, AIX at the time.
Okay. So what fascinated you back then? So you remember something you did in the leisure or something with programming, What
what was interesting was when I wrote the program, I could take it, pop it, and bring it upstairs, and people could try it out immediately. Mm-hmm. So people, those were not programmers, those were business people trying out my stuff. That was very satisfying to me.
Mm-hmm. Okay, this is really interesting. So this is like beginning of Agile, right? You're going upstairs, and you can try immediately what happened, right?
Yes. Yeah. I said I went upstairs, not downstairs, because those guys were higher on a higher level than me, and they were business guys or business ladies, and they tried out my stuff, and that was very satisfying. It's the same now. It's the same motivation. I write something in JGroups. I add a new feature, and people can try it out, and that's very, very satifying for me.
Could it be that it's somehow related to the business ladies as well? Your motivation to going up?
I don't think so.
Very good. So you started with C at IBM. What you did then? You stick with system programming, and what also interests me, what was your topic of your PhD?
The topic of my PhD is very boring, and it was basically before I got there, I actually picked up C++, and those were the first compilers, Glockenspiel and Turbo, something on Windows. I actually programmed Windows as well, and ancient system called OS2.
Okay.
And then my PhD was about basically accessing different systems from one system. So basically trying to get the meta model of various systems like Corba-based systems, and then generating code that would transparently access the different types of systems.
But it's interesting, actually. So you wrote as stubs and skeletons, more or less, right?
Yes. Kind of. Corba was coming on then. So one part of the system was accessing Corba-based systems, and the other one was accessing an ancient system consisting called CMIP, CMIP. I don't even know what it stands for anymore. And this was written in a language called GDMO, Guideline for the Definition of Managed Objects, a very hideous language.
Okay.
And the data part was written in ASN1, or basically defined through ASN1.
Mm-hmm.
And I came up with a system that would use the metadata or the input ASN1, GDMO, and IDL on the other side, and basically generate metadata that could then be used at runtime to access the different systems.
Okay.
So it was like an overarching system to access, transparently manage systems based on different principles or guidelines.
I also started with C. I started with Basic and Pascal, similar to you, and C, and then I find out C++, and how I found it is because of Linux and Björn Strustrups. I remember his book. It was like a thick book from Edison Wesley, and I was fascinated by C++. What I really like, the C in and C out. I remember this was like the operators, like the lesser and larger LT and you know what I mean? And I played a lot with operator overloading. So I tried to overload everything, just for fun. And this was, And what was really frustrating were the templates under Linux, because you had to do some magic stuff to make them work. So I was really, I didn't like that because I couldn't make it work. So this was my problem.
Exactly.
Yeah.
Exactly. And the syntax was very ambiguous. The C out, if you had a white space between the two brackets, then it would mean something else. I remember an old friend of mine, Jim Waldo, showed me an article about how template evaluation could be used to compute the factorial. And that was when I said, that's enough for me. I have to move away from C++. And actually, I wrote this on my IBM Research homepage. C++ is crap. Hopefully something will come along that's better. And Java came along.
Oh, interesting.
Yes. So the templates, I remember you either had to write all of your implementation in the interface code, or you had to use magic repositories. I think Borland compiler used that approach, and Pragmas to actually...
Yeah, exactly. The Pragmas. I remember the Pragmas, yeah. And what I also found out that the templates were Turing complete. So for me, it was like, crazy, because it was just another language inside the language. But then I couldn't make it work with Pragmas on Linux. It just didn't work for me with I remember G++ and GCC, whatever I did back then. And then Java was on the horizon, JDK 1.0 or Oak in my case. It seems in your case was the same. By the way, do you have somewhere your statement? Can you put it to the show notes? You're like C++ is crap. You have it still somewhere?
Yes.
Oh, this would be cool. We have to add it to the show notes for sure. This would be, why? Okay. And you started with how you got to Java.
Oh, Java. My friend at IBM Research, he went to Darmstadt, and that was the first World Wide Web conference, or the second, I'm not sure. And he brought home Java. Mm-hmm. And I said, what's Java? So he showed me the nice applets, and I was hooked immediately.
Okay.
And so basically, we were the first.
Sorry, what was the name? What was the name of the conference? Remember?
I think it was the third or second World Wide Web conference. I think it was called World Wide Web Conference in Darmstadt in Germany.
Yeah, this is crazy because I never heard about that in Darmstadt. So.
Yes, I didn't know about it either back then. And he brought back Java. At the time, it was called Oak. Inside the directory structure was all Oak. And he showed it to me, and I thought it was really, really nice. We were also the first, one of the first team in Switzerland to put up a web server. NCSA, I'm not sure. Mosaic was the browser. This was at the time, it was just more or less invented by Tim Berners-Lee, I guess. Mm-hmm. And we were the first ones to set up a Suit
server. Suit spot,
something
right?
like that. Yeah. long time ago. So I looked at Java and I liked it, and looked very simple compared to C++. It had garbage collection, or C or C++. It had garbage collection, so I was hooked. Unfortunately, I was still stuck in 2 C++ projects. So it took me another half a year until I could jump to Java.
Uh-huh. And what was your first Java project then?
My first Java project was a application that was written to extract data from a mainframe system or some MVS system or so at IBM Research. So it was written for a customer, so it wasn't really something that I would have done on my own. I was using, I'm not sure if I'm saying this wrong, but I think I was using JINI or something like JINI to actually access a C-based system that I had written. So trying to convert that application to Java. But it all started, real serious Java use was at Cornell later.
Oh, so you moved from Switzerland to Cornell.
Yes, I was interested in after my PhD and doing a postdoc. And I was offered a position as researcher at Cornell University. And I moved there 2 years. And that's when I started Java. Or basically, I used Java from the onset.
And you used the Sans Java, the JDK 1.0, the Sun version, right?
Yes. Okay. Yes, I guess so.
Okay. And so what you did then? You stick with Java, seems like. So what happened? So your first project was probably successful, I guess?
Yes. At Cornell, we had a group consisting of 4 people. Ken Berman, the Pope, he's the guy who kind of invented virtual synchrony, a paradigm in distributed systems programming. Robert Van Rennes and Werner Vogels, who is now, I believe, the CTO of Amazon.
Yes.
And we had a system called Ensemble, which was a group communication system. And it was written in a language that's very hideous. I didn't like it at all, called Ocaml. So basically the object-oriented version of Caml. It's a functional language, but it looked like the file had been encoded when you read it. It looked hideous. I did not like it at all. So I ended up teaching 2 courses, CS 101 and CS, I think, 405 or something, the distributed systems programming course. And my students wanted to actually program distributed systems, write their protocols in Java, not in Ocaml. So I ended up writing a thin layer over Ocaml.
Now it is different. That Ocaml is like the funky language, So Java is, so everyone says Java is crap. Now we have to learn Ocaml. Back then, students hated, Ocaml and wanted to have Java. So I would say you only have to wait 20 years and everything repeats, right?
Only have to wait for 20 years. Well, it's a functional language. The concepts are nice, but it's just the way they architected the language. I didn't like it. I like other systems like, I'm a Common Lisp guy. I used to write a lot of Common Lisp code back then. It's much nicer. Or Clojure. I looked at Clojure a couple of years ago. I like it. But back then, Ocaml was the way to go, at least at Cornell. So I decided to write a thin layer, hiding Ocaml behind a thin Java layer. And over time, I replaced the Ocaml stack with a Java stack. At that time, I called it JGroups. And it didn't have a lot of functionality. It had basically discovery, join, leave, send messages, receive messages, blah, blah, blah. And I basically wrote that for my students. So my students could start writing distributed protocols.
I'm just wondering, because back then I think it was the JDK 1.1 timeline already. So what was your opinion about JINI? So JINI was probably around back then, Java Intelligent Network Infrastructure. And I guess you didn't like that, right?
No, I did like it. As a matter of fact, Jim Waldo, who was leading the JINI project at the time, and I had met before. And so I guess I can say that now. At the time, Sun Microsystems and Cornell were working on a collaboration to make JINI distributed, JINI not distributed, but reliable using JGroups. Mm-hmm. And so we were almost joining for a collaboration on that, Sun Microsystems and Cornell. The problem was that Sun Microsystems wanted to keep everything secret and Cornell wanted to publish. And so this never saw the light of day. But it could have been, had this project proceeded, it could have been that JINI would have been made reliable using JGroups, using JGroups. It was called JGroups at the time. Mm-hmm. So I did like JINI. I did like RMI as well. Mm-hmm. So the collaboration was JINI/RMI, mm-hmm. make it reliable, make it redundant.
And what I liked in JINI were the concepts, because you already did the concept of the lease. This was the, I would say, for me at least, revolutionary concept, where you had to resubscribe yourself, over and over again. And if you forgot to subscribe, you would just disappear from the network, which provided you with kind of self-healing, which I really like. I still, the idea is still in my projects from back then. So it was, for me, it was like really interesting and completely different to anything else was around at Sun Microsystems back then.
Yes. I think the problem, the reason JINI died is that they changed the message a couple of times.
Yeah, the marketing was terrible. So it was like in Germany, they tried to sell, to distribute printer drivers with JINI. And I say to Sun, you are all crazy. I mean, who will buy technology to distribute printer drivers? I mean, this is completely pointless. But if they would marketing, JINI as a SOA, it would take off completely, I would say.
Absolutely. It was a good technology, but nobody, they didn't have an elevator pitch. I guess if you can't say in 30 seconds or in 2 sentences what your product is about, then you're already lost.
Yeah.
And that was the problem with JINI.
Yeah. Or, back then, just building load balancers with JINI was also perfect, because you could discover or give me, all, for instance, interfaces on the network, and you can sort them according to, I don't know, CPU usage or whatever you like. So, I mean, the whole discovery mechanism was great. And this was 1999. It was 20 years ago. So this is actually the interesting part.
Yes.
Yeah. So it seems like, also funny, Sun tried to keep everything secret, which is not that obvious. And then you, I think, keep moving with JGroups, right? With JGroups.
Yes, it was called JGroups at the time.
Yeah.
And
like the Java Polis conference was also called at the time Java Polis, and at one point of time they had to rename that.
Yes. When I moved to California after Cornell to Fujitsu Network Systems, I had lunch with a bunch of guys I knew back then, like Brian Goetz or Bill Shannon. And Bill Shannon, once I went to Sun, we had lunch. He once said, Bella, it would be nice if you renamed JGroups to JGroups. I said, why? Oh, we have a trademark on Java, and it's possible that you could end up with a cease and desist if you continue using the name Java in your product. Mm-hmm. So I decided to look around and find another name. I was looking at what is JGroups. It's about multicasting. It's about flexibility. So let's try to use the name FlexCast. Mm-hmm. And I was Googling for FlexCast. FlexCast is a cast. If you break your leg, it's a cast. And so I couldn't use that. And by the way, flexcast.com was already taken. So I said, why don't I just call it JGroups instead of JGroups? Mm-hmm. Some further Googling around, I found out there's another project called JGroup, and run by 2 Norwegian guys. And I said, okay, let's look at the website. And I saw they had like 2 downloads a week. And so I asked him, would it be okay if I call Java groups JGroups? That's very close to JGroup, but you have 2 downloads. Your project's basically. He said, no, it wouldn't be okay. And I said, okay, fine, I'll do it anyway.
This is psychology again, right?
Yes. And I wasn't very good at it. But for me, it was important that I avoided the trademark problem. So I ended up with JGroups.
So Bill Shannon is actually also an amazing guy. So with a conversation back then, he's a mathematician, I think. And he's a 0 or 1 guy, so at least from my impression from the outside perspective. And we had a chat up regarding Java EE APIs, and what Bill Shannon did, because it was logical, and it said, okay, now we have I think it was Java EE 5, I guess. What happened was because from legal reasons, this Java EE API was only supposed to use for compiling. He created a tool and removed all the bytecode implementation from abstract classes. So you could compile against Java EE API, but if you wrote a unit test, you couldn't load the library because then you get an error, class format error. And I say, hey Bill, I mean I know what you mean, but it has to be changed. And after I don't know. I would say 1 or 2 years, he changed that, and I say, okay, let's go. This is not correct, but it could work. And he just removed his own tool, and now we can use Java EE API or Jakarta EE API now anyway to run unit tests against that. So we can actually load the API to with class for name, right? And you mentioned
he's a very nice guy.
Yeah. And really nice guy, and he was a great guy for Java EE anyway. So he tries, it still contributes a lot to Java EE. And Jim Waldo wrote also an interesting paper called Note on Distributed Computing.
Yes.
And this is interesting because the whole back then everyone thought about there was at conferences talks about transparent remoting and distributed computing. And he just wrote, if you distribute a system, it will never behave the same as a local one. Which is very true, and you cannot just abstract away distribution, right? So
the 8 fallacies of distributed computing.
Yeah,
the network is there are no failures in the network.
Yeah, exactly.
I think that was the big problem in RMI as well, possibly Corba, because people assumed that the network was reliable.
Yeah,
and that exactly what you said. Yeah,
very good. So so back then, you renamed JGroups, and you still just use JGroups for teaching? No.
When I left Cornell, I actually put JGroups on SourceForge, and I think that was in May of 2000. Okay. And SourceForge had just been founded in January of 2000 or something like that, just a couple of months ago. And I put it on SourceForge in the hope that somebody would take it over, and it's my little child. It's 2 years old. I want someone to shepherd it through life, or maybe I don't know, just to give the possibility that someone would pick it up. And then I went to Fujitsu network systems, so basically doing something else in Java, but still something else. And then people started contributing to JGroups and sending me patches and stuff. And so it was semi-alive. Turns out at Fujitsu, we were in need of a system that was able to find out the nodes in a cluster, to send messages to the nodes, individual nodes, to all of them, to receive messages, to get notifications when nodes died or were started. And turns out I was starting to write something like JGroups. So I asked my manager, is it okay if we actually use JGroups? So I don't have to reinvent the wheel. He said, okay. And so we started using JGroups, and I spent about, I don't know, a fraction of my time on JGroups.
What was it in Fujitsu? Can you talk about that? What system was it, roughly?
It was a network management system. We had optical switches, and customers were given a management system.
Mm-hmm.
The management system needed to find out where the switches were and manage them. And this was all done using this network management middleware, if you so wish,
And
using JBoss.
how long were you stayed at Fujitsu?
Oh, I stayed there from 2000 till 2003. It was a bad time. You remember the dot bomb,
Yeah.
Pets.com, Webvan, all those companies went belly up, and we had strong competition. We had Nortel, we had Cisco we had Lucent as competitors, and they would do everything to get a bid, to win the bid. And so they undercut their prices, and we were going through 3 rounds of layoffs. I was in a nice position back then. I made good money. The product was more or less in its maturity cycle. And I was hoping that they would lay me off, because if they laid me off, I would get 3 months of severance. But that didn't happen. And at the time, that was actually 2002, Mark Fleury contacted me, or actually earlier on, Sacha Labouré, who wrote clustering in JBoss. And Mark Fleury, the founder of JBoss, they contacted me and asked me to join them. And I said, no, I'm very happy here, and I make good money, and, I don't join a small startup like you. I actually had to Google, what is JBoss? I didn't know JBoss. I didn't know J2E back then. But it was kind of getting boring at Fujitsu, and everybody was afraid of getting laid off. So at one point, Mark convinced me to write a cache for the application server, a distributed cache, and I called it JBoss Cache. And to do that, I had to take unpaid vacation. So I took unpaid PTO. I think it was 6 weeks. And we actually wrote that for a big telco company. And so I was paid by JBoss at the time. Coming back to Fujitsu, there were more layoffs. I was still not laid off. So Mark asked me, why don't you join JBoss? I said, no, that's too risky. And so he kept calling me and blah, blah, blah. And so I decided to ask my boss to take another 2 months off unpaid. And he said, no. I said, why? You don't need to pay me. I mean, during the time you're laying off people, but you wouldn't have to pay my salary. You would be paid by JBoss. He said, still no. So I said, okay, I quit. I resign right then and there. And then I called Mark and said, hey, Mark, I just resigned. Can I join JBoss now? He said, Bella, do you play poker? I said, no. He said, yes, I know, because you just showed all of your cards, and you shouldn't do that. But no, it's just a joke. When can you start? So I joined JBoss in 2003, early 2003, and started working from home in California.
Very cool. And Mark Fleury is also an interesting guy. He wrote, are you aware of I think it's called Blue Paper from Mark?
Yeah, there's 2, blue and red.
I think the blue one is how he applied to BA. And they say, yeah, we don't like you. And then he started, the EJB or Game Over project, something like this. And then he renamed it to EJB Boss, and then was JBoss, I think, right?
Yes. I think it was called EJB Open Source System, EJB OSS. And then there was a trademark on EJB, and so he removed the E. And
Mark, I think this is like a special forces guy, right?
Yes, I think he joined some paratrooping unit in France, I guess.
Lots of interesting guys. I would say, and you started at JBoss. How was it?
It was interesting. I was thinking, oh boy, what have I done? Because I made about 20 to 30% less than what I made at Fujitsu. But I could make it up by doing consulting and training and stuff. And so turns out 2 weeks after joining, I did not know J2E at all. I was teaching a J2E course. So I was thrown into the cold water, and I was doing up to 70% or 75% consulting at the time because there weren't enough people around. So I traveled to companies. I did consulting, support, and trainings. And turns out I actually made more than what I made at Fujitsu. But that was just a coincidence. I was just happy to work on something that was interesting, that looked like it was a very new technology. It was very exciting to do caching, distributed systems in JBoss or in the project JBoss Cache, and that was very satisfying.
But the very first JBoss Cache, it was a tree cache, right? This is what you wrote.
Yes, actually, the day before we announced it, Mark called me and said, let's call it True Cache, not Tree Cache. And I thought maybe there was like a mistake. Maybe he didn't read my writing correctly. But then I Googled True Cache and it was already taken by some. So we didn't have a marketing person back then. We didn't have legal back then. So basically we decided it would be called JBoss Cache. Not a very good name, but for lack of a better name, we just called it JBoss Cache back then.
Because it started as a tree structure, and then a couple of years ago they moved to a hash map or map-like structure.
Exactly. We decided that couple of years later, I handed over that development to a chap called Manik Surtani, because I wanted to focus on JGroups after 2 years working on JBoss Cache. And so at one point we decided that it should become a regular cache, something like Coherence, more like Coherence, hash map, a replicated hash map. That's also very simple to understand how it works, and also simpler to implement than a tree structure.
Yeah, I assume locking is really challenging in a tree if you write something, because you have to lock up all the nodes.
Yes.
I met Manik in a taxi in Poland somewhere. I think it was around 2008. He asked me, what about having a cache with a map inside of a tree? Is it a good idea or not? What are you thinking? I'm like, I would say it is good enough, This was funny. This was Manik Surtani I forgot the name of the conference in Krakow. It was in Poland, but yeah.
Yeah.
Nice. So you stick with so what seems like you were the master of JGroups, of JBoss Cache, and then you did JGroups again.
Yes, I went back to JGroups, and I remember I always said version 3 is going to be the last version that I'm going to release. But turns out it was quite successful, not just inside of products sold by JBoss or Red Hat later, but also as a standalone project. I have a lot of people who were using JGroups as a caching implementation, or JBoss Cache caching implementation inside of WebLogic or WebSphere. So they could actually purchase the standalone version of these products and implement clustering themselves. This seemed to be a very popular use case.
Yeah, but now it's called Infinispan, right?
Yes, JBoss Cache is now called Infinispan. The product is DataGrid, Red Hat DataGrid, and right. And it doesn't look. It's hash map based.
Yeah, and so the JBoss Cache is like hash map which communicates with other nodes using JGroups, right?
Yes. JGroups is still used as the clustering layer underneath. So basically, discovery, what are the nodes in the cluster, sending updates through JGroups, receiving updates, receiving notifications when a member crashes or leaves or a new member joins, stuff like this. Yes.
Okay, very good. So you moved the JBoss Cache responsibility to Manik, and then you stick with JGroups until now, I think, right? So this is the
there was a small detour I made. At one point, I was interested in the CAP theorem. Basically, our system is more or less AP. So I was interested in doing CP, consistency, and partition handling. And I was very interested in RAFT and RAFT technology. I read the dissertation by Diego on Garo, and I started implementing this on top of JGroups. And I actually ended up with a complete implementation of RAFT on JGroups. It implements the full dissertation. And my idea is still, I'm not working on this anymore. It's called JGroups RAFT. But my idea is still, or the intention is still to go back after I'm done with JGroups. But right now, there's so many things to be done in JGroups. Maybe I'll talk about that a little later. But so I hope I will have time to go back to JGroups RAFT. I know people are using JGroups RAFT, even in production. And we're thinking of using JGroups RAFT too, maybe in the future in Infinispan. Well, we'll see.
Okay, so now you mentioned RAFT. So you also have to mention Paxos then. And
yes.
My understanding is that Paxos is more an abstract concept, and RAFT is something which can be actually used. It's a more pragmatic explanation and implementation of Paxos, right?
Yes, Paxos is just too complicated, and I wouldn't pretend I understand it completely, but there are many implementations, there are many proposals to make it simpler. Also one by my colleague Robert van Rennes, Paxos made simpler, I think, or more efficient or better or what have you. So it shows that there's just a complexity in Paxos, and I think that's the reason that there are so many people jumped on RAFT, and there are so many implementations of RAFT.
And what RAFT basically is a leader election, right? So we have a distributed system. Is always the problem. So nothing is really distributed. So actually, my understanding is to have a distributed system working, you actually need a local system. So you need a kind of singleton, and everyone agrees the singleton is the master, and everyone else waits until the singleton dies, right? This is the basic concept.
Right. I guess it's a simplification of Paxos. You don't do leader election on each round, on each update, but basically do it once until that leader dies, and then somebody else takes over. It's a very simple to understand concept, and I guess it could also be more efficient. But as I said, I'm not an expert on Paxos.
Yeah, but this is also RAFT. So this is what RAFT does, just for the listeners. It's just leader election system. So the problem is if we have, let's say, 5 nodes of a cache, to be consistent, what we have to achieve is that the writes are sent to the master. And if we like, we could potentially read from the slaves. But there should be one, instance, which is the consistent instance. And anything else is like for failover and availability and whatever. This is the basic idea. So we need the master, and the master election or leader election is a RAFT algorithm, right?
Yes, correct.
Okay, and there is several RAFT simplifications. What did you say? The classic RAFT, I think, is the leader has to be re-elected every time, and there is I forgot the name, a optimization of RAFT where you can keep to having the leader all the time. So there are several flavors of RAFT, but one question. So JBoss always had the distributed singletons, right? So JBoss from the beginning had the possibility that you can launch a singleton, and all the JBoss slaves waited until the singleton dies. So this was RAFT for kids, or what was it back then?
It was RAFT for kids because it didn't really take the P in cap into account. So the partition, it didn't tolerate partitions. If you injected a partition into such a system, you would end up with multiple singletons.
Yeah.
So this system is useless, to be honest, unless and until you base it on a system like JGroups RAFT, which allows for only one singleton or none. So basically, it sacrifices availability over consistency, and unless and until you can live with multiple singletons, which I think most applications can't. This system is really for kids.
Okay, so just because you mentioned this right now, so funny story. A customer of mine asked me once, we have 2 cluster nodes and it has to be highly available. And they had replica factors of 2 and 2 nodes. And so what they actually did then is, if one node dies, you cannot write, You say, okay, if one of your nodes dies, then it's over.
Yeah.
You will just, this is what you said right now, one or none. So you are consistent, but the system is useless, but consistent.
Right.
This is one of the trade-offs. What also, funny side note, Java E had singletons. And there was expectations that the singleton have to be replicated. I say, hey, this is no way to implement that. So for Java E, we cannot just, magically implement, the RAFT somehow. It cannot work. There's also misunderstanding what Java E singletons or application scope beans actually can be.
Yeah. Yeah. Also, the problem is if you have state and there's a partition and the state is replicated and state is supposed to be available only once, how do you reconcile the state? That's a big problem. Most of the time, you have to call a function in user code that says
vector clocks.
Value. Exactly. Vector clocks. It's something like the Amazon Dynamo system, which also calls back into user land to reconcile state, and that's always very difficult.
Question about the JGroups RAFT. I didn't look at the API. So how hard is it to use? It's just say, launch, give me the leader and you are done? Or is it harder than this?
It's actually very simple. There's a handle to a RAFT implementation. The RAFT is about distributed state. So you have to implement a state machine. Mm-hmm. It's just an interface that says update with a byte, basically a byte array, and get with a key that returns a byte array. So that would be the state machine. You can run it without the state machine, but then it's more or less useless. And then there's a set, there's a get, I think there's a remove. So it's very simple. It's kind of replicated state machine based. So it's a very simple API and requires a persistent backend. We're using RocksDB, and it's very simple to use.
Are you using RocksDB? So you're almost at Kafka level then.
Yes, well, the backend, the persistent backend is pluggable. For unit tests, we're using something that's called in-memory state. So it's actually a persistent database that's just in memory. So when it's gone, it's gone. So it's not really persistence, but for unit tests, it's good enough.
Do you know MapDB?
Yes, we used to use MapDB, and I'm not sure. I would have to go back to JGroups RAFT to see if it's still supported. At least we had MapDB. We had 2 implementations. One was MapDB, the other one was RocksDB, I think.
Okay. So what the state machine is just has to remember what happened in order if the node dies and comes back that the node knows what happened, right? This is the whole idea of the persistent state. Yeah,
the state machine or the persistent state basically just is a log, an append-only log. And we're appending updates to the log, and there's 2 pointers. One is a commit pointer and one is an append pointer. Mm-hmm. So commit means everybody's agreed on that the commit pointer should be moved forward. So those records that are included in the commit pointer are part of the state, and the others aren't. And every now and then we do compaction or snapshotting, and basically we're shortening the log up to the append pointer. And it's a very simple API. It's pluggable, so you can plug in your own, persistent engine.
Mm-hmm. So JGroups is also a nice and simple API. So basically, it is one interface, is JChannel, I think is the name, right?
Yes.
And you can send and receive messages through that. And I think the main idea of JGroups, is my understanding, is UDP, so it's very fast, but it's also reliable. So you wrote on top of UDP some, I don't know how to call it, quality of service implementation, which assures that actually the messages will arrive, right? This is what JGroups basically is.
Right. Well, first of all, JGroups is very simple, and I want to keep it that way. It's like join. You have this J channel, as you mentioned. You have this endpoint. there's a join method, there's a send receive, leave method. So there's 5-6 methods that you will ever need if you use that endpoint. And it is based on a protocol stack, which includes a transport. So the transport is used for sending, could be UDP, it could be TCP, it could be RDMA, which is on the to-do list, it could be NIO, it could be Netty. And basically that's used for sending and receiving of messages. But as you said, this in itself is not reliable. So UDP is not reliable. Packets can be dropped, blah, blah, blah. And so we need to add some reliability layer, some retransmission layer, which tags every message with a sequence number, and then you deliver the messages in the correct order. If there's a gap in the sequence numbers, you retransmit. You discard duplicate packets, basically what TCP does with IP. And on top of that, you can add, and that's also protocol-based, you can add encryption, compression, auditing, statistics, whatever you want. You can implement your own protocols. So JGroups is basically very extensible because you can write your own protocols.
Question: why you with re-implementing TCP in Java with UDP is more efficient than using just TCP?
Some systems, when you have 200 nodes, and you want to send a message to the 200 nodes in TCP, you would have to send 199 messages. So you have 100 nodes and you want to send one message, one virtual multicast. You would have to send it 99 times for every recipient. With UDP, with IP multicasting, you could simply just send a multicast, and that's much more efficient than sending 99 TCP messages.
So what it means is JGroups, if you have a few nodes, TCP would be more efficient, and if you have the more nodes you get, the more JGroups will pay off, right?
Yes. So what I'm saying is, this is the JGroups gives you the flexibility to use the same application. The API is always the same, but to replace the protocol stack with one that's adapted to your networking environment. So you can, if you want to use TCP, or if you have to use TCP, for example, in clouds, most cloud providers at the time being don't provide UDP or multicast support. You have to use TCP, then you can do so. But you can add or remove stuff you don't need.
Yeah. In one point of time, I delivered a workshop, Java E workshop. It was the IT, how it's called, the workshop target from the Java user group, Swiss Java user group, from and this was in Zurich. And there was one guy, I think it was professor, and he told me there is a guy, Belaban, and he has a huge cluster of Sun machines, I think in Lucerne, and he's a lab, and he just tests all the time JGroups with multiple machines. So that's actually interesting. I will have to talk with him in one point of time. And of course, it was 5 years ago or 7 years ago, but I remember that. So what you did in Lucerne with the Sun cluster machines, and how big was the cluster?
This is interesting because it was a lab that was opened. Actually, let's go back at Java 1. Decades ago, I gave a talk at Java 1, and then there was this one guy, probably we're talking about the same guy, who walked up to me and with a funny Swiss accent and said, I'm from Switzerland, blah, blah, blah. We have so we met. And then when I came back to Switzerland, he invited me to the big opening of their new lab sponsored by Sun. It was about $3 million, and Sun spent about $2 million. And the rest was donated by the Swiss government. So it was a huge Sun cluster. And he said, would you like to have access to it? And I said, yeah, of course. I'm always interested in running performance tests on huge labs, huge clusters. And so we met, and then it was very nice. It was a big reception, and they opened it officially. And it was the biggest and fastest Sun machines at the time. Hardware. But I had to do something in return, I had to teach a course at the university, and I've been teaching that course for almost 15 years now.
Oh, very good.
So, yeah, but I got something from that. And by the way, talking of big labs, I have friends at Google who gave me access to their big clouds before anyone else was on the cloud. So I was able to start a cluster of 2,300 and something, 2,000 plus nodes and run JGroups on that. That was very impressive.
Yeah, and it worked well? Better than expected?
Yes.
Or?
Actually, the bigger problem was to get the 2,000 nodes started because they had the G-Cloud. I'm not sure if this is still the case. The G-Cloud command was based on Python. And turns out I was running out of Python file handles when I started the huge cluster. So I had to start them in batches of 200 or 300 nodes at the time.
Okay. What strikes me, I mean, this JGroups is like, how to call it, expert knowledge, but it's very easy to use. And people try, to find more and more solutions, which are crazy complicated. They look like Corba almost, always. They never mention Corba, but it looks like Corba. So the history repeats again. They say Corba is crap and bloated, and now we have something like gRPC. If you look at that, it's actually exactly like Corba. If you try to integrate with Java, it's pain. Actually, it is, and the whole reactive programming makes sense in some cases, I would say. But if you just would like to call another service, just call a method or just just invoke a method, it's just golden. I would say it's just very simple. And good
point. Good point. I'm very curious. You talk about reactive programming. I'm not sure if I really like it. I kind of like it, but I think it's very difficult for application programmers, like the callback hell in JavaScript. And so I'm very interested in seeing what happens with Project Loom when we have fibers. And the fibers are supposed to be like green threads, but much more efficiently done. They don't block. And so they don't never block the carrier thread. So I'm very interested in seeing, I've heard of experiments where people were running a couple of million threads on their laptops. I'm very interested to see if this is going to kill reactive programming, to exaggerate.
I mean, the reactive programming, I would say. So the problem is people like you go to conferences. This is the actual problem of IT. People like Belaban. Why? Because you started 2,000 cluster nodes at Google. You go to conference and talk about that, right? So then the developers hear you. They go back to home. They have just one cluster node, but they would like to have reactive programming and 2,000 nodes for a guestbook application, And they try to write overcomplicated systems. So I would say the Loom could be interesting if you build a cloud or platform. So if you're building a business apps, less so. And reactive programming is the same for me. So sometimes it is just natural to use reactive programming. If you have, let's say, a feed of events somewhere, right? So I receive data from somewhere, then it's very natural to me, to have something like a data structure. It looks like stream in Java. I map it to the feed, and I'm just going with that. So I filter, do whatever I can, and I just write the data out, and I'm done. But if I have a request response mechanism or I need a user interface, either I will do everything reactively or nothing, The problem with reactive programming, you cannot break it. So if you have request response at first and then you start with reactive, it's a mess. Because as you probably if you have an asynchronous method call, it's really hard to block somewhere, because the question is how long you would like to wait until something happens, what happens with exceptions, what happens with poison messages. This is the problem. So I would say reactive programming is great if everything is reactive. So then it's just natural way to go, but you cannot just mix the things. And most business applications are just boring. We have a database, it's already there, and we need to have some kind of REST API for JavaScript. And then we are done. And if you start, to be fancy somewhere in between, it gets more and more complicated. This is the problem.
It's a hype.
Yeah,
it's a hype. And I'm if I had to read up on the latest technologies, the latest hypes that come up, I'd be busy spending my day doing only this.
Yeah.
So what I do is I ignore all of this.
Yeah.
I don't look left or right, but every couple of months, I take a few, maybe every half a year, I take a mini sabbatical, couple of weeks, and look only into the hypes. The advantage of this approach is that you can skip hypes that are dead by the time you start looking into them. For example, asynchronous programming. I think it's very nice, but it's overhyped and it's not the solution to all problems. So a lot of people think it's the solution to all problems and start writing all their systems reactively. I think that's wrong. So Project Loom, I think hopefully we can go back to the request response kind of blocking semantics. But you don't block the underlying thread. So if you had a system that was not reactive, but more or less request response blocking paradigm, perhaps with Project Loom and Fibers, you can just continue using it without any major changes. And that would be beautiful.
Yeah, but this is like, optimization behind the scenes where as a business developer or application developer is not, that exciting. I'll say for us,
Right.
What I would like to mention is the problem is, one single application server, let's say, Whitefly is just too fast. It is amazing how much load a single application server can actually process. And and therefore everything becomes boring. I just coaching some startups. They some of them using Whitefly. I assume majority of them using Whitefly right now, and some of Quarkus. And they keep me asking, we do nothing to optimizing the performance, and it's just crazy fast. So how they do it? It's like because they do nothing else for 30 years. So everything is optimized. We have Java, everything is great. There is no need, and they are just confused. They ask me, what about reactive programming? It's like, if you like, do it, but do you have a problem? I mean, we have a lot. It is there is no crazy RAM consumption. The CPU, everything works smoothly. Why you would change your code? And so I think reactive programming is really nice. You have to know about that. And in user interfaces, for instance, could be something different, because if you can consider a mouse like a feed, like a source of events, and you can react to it. So you could do this. But this is just another. It's not like it changes everything. It's just another option. And asynchronous programming is even worse. So you know Java E probably. So in one project, people wanted to be funky and did everything asynchronous. So they put a lot of asynchronous annotations on the methods. And what problem was, the queue is bounded. The amount of threads was set, so was also bounded. And what happened then is, if you call from one asynchronous call another asynchronous call, and it creates another HTTP request which lands in the same queue, you get stuck. So in one point of time, all the clusters went down because there was not enough threads to process. And we switched back to request and response, and it works until now. No problems, very fast. There was actually solution to a problem which didn't exist. That's the problem.
Right. I mean, if you give everybody only a hammer, then everything is a nail, or perceived to be a nail. And I guess, as he said, look at the problem, look at whether performance is good enough. If it's good enough, fine. If it starts hitting the wall, maybe you should start looking at asynchronous programming or reactive programming, or maybe start experimenting with Project Loom, which requires fewer changes. And don't just use reactive programming because there are people at conferences give talks. I call them the PowerPoint monkeys. They preach that that's the next best thing, and so everybody does asynchronous programming or reactive programming.
But if you come back just to reactive programming, when it could make sense, let's say we get reactive JDBC drivers, which what it means is we could, for instance, say I would like to read from the table, and then asynchronously would receive the updates. So if you do it from the UI, so the UI calls without blocking, let's say with WebSocket in JavaScript, it goes to the REST, and the REST method is suspended asynchronous, so it's just one way, fire and forget, goes to database, and through another channel we receive the data and comes back to the user interface, and everything is asynchronous. This is beautiful. So this is simple. Yes. But you cannot just use traditional REST in the front end and then just reactive JDBC drivers, because in one point of time you will to block somewhere, and this, this destroys the whole nice concept.
Agreed. Yeah.
Cool. One optimization I could give you, you will have to redesign the jgroups.org page. And the easiest way to do this is, no kidding, I also did it, is you have a GitHub account with JGroups. You can have a static templates. It takes 15 minutes and you get a great looking JGroups page based on GitHub from GitHub Pages.
Excellent. When are you going to send me the PR?
It is hard, but what I can send you is one of my projects where you can just copy and paste the what I did. But I could probably one point of time do the PR. But, the problem is, the colors, the fonts, you will have to be a little bit creative, Bella. So if this is...
I wasn't actually. If you have you ever looked at the Apache HTTPD page? I mean, this page, the JGroups page, was copied. I'm a thief. It was copied from Apache.
Yeah.
And it looks like it looked 20 years ago.
Yeah.
So
the problem is the gRPC pages are looking better, They're all reinvented Corba stuff. So, and I would really like to use JGroups a little bit more in my projects. So we need a nice design. By the way, we skipped one important thing. So Quarkus. What you did, you exposed JGroups as a Quarkus extension, where we can really inject with @inject JChannel into Quarkus, and this is actually great.
Yep.
So
I think it's, I experimented with Quarkus before it was public, and it was Sane Grinovero. He's the Hibernate lead or Hibernate search lead. He's now in Quarkus. Mm-hmm. Him and I, we had a session half an hour or 45 minutes, and we ported JGroups to Quarkus, which shows that it's very that the code is actually very, very nice. There was one major change we had to make. It wasn't really major, minor, and it was working on Quarkus. So I'm very excited. I experimented with this a little bit. You can get a simple application based on JGroups, standalone JGroups application, running in starting in a millisecond. Mm-hmm. So it's very, very nice.
Have you not noticed any optimizations just in the hotspot mode, or just?
Yes. Well, I think you're mentioning the Java mode, the hotspot mode.
Yes.
That's actually, I'm told that's the most frequent thing that people are using. They're not using the native image, but they're using the hotspot, the optimized image, because then a hotspot can still optimize stuff.
Exactly.
To be honest, I focused on the native mode.
Okay.
The thing is, the native mode is less performant than the hotspot mode, but it's always uniform. Every run yields more or less the same result because there's no optimizations done at runtime. Mm-hmm. Hotspot, to be honest, I haven't experimented with.
Okay. What you told me that you do a few weeks a year, like hunting the the hypes, and what I actually ignored, all the whitefly swarms and thorntails. Actually, at Java 1, there were the people from Thorntail team, I think, and they asked me about my opinion, and I was politically correct. I said, I don't see the point. As a whitefly is fast enough. I have no idea what you're doing with the whole Thorntail. As for me, there is no problem or solution without a problem. But then, Quarkus came up, and it's like another runtime. When I took closely a look on it, and what this is actually what was excited from day one, and not just because of the performance, because what I did back then is lots of microservice development, and in microservices, what we misused Whitefly or Payara or OpenLiberty as the efficient and I would say usable runtime to implement business applications, and we had always one-to-one relation between the application server and the war. So what we basically did, we had one thin war. We shipped that always in a Docker containers one-to-one with the server. And I was happy because the servers were small. And what Quarkus was for me, it was, a consequent optimization of the idea. And what they did is they just deploy at build time. This is what they did with tree shaking and everything. So what it means is it happens exactly the same what I did before, but this is optimized. So this deployment doesn't happen, just because they find a war in a folder, scan it, and apply reflection to load it, which causes a lot of unnecessary bloat, I would say. what they do it up front. So they build everything with some interesting side effects. They will find, easier CDI errors. So for me, it was genius. If I saw this, it's like, hey, the first time I see something which actually makes sense. And now it's smaller and whatever, but I mean, the idea is great.
Yes. I like the KISS principle too in my software. Keep it simple and stupid and small. When I can remove stuff from JGroups, and I will, I'm working on 5 now. I just released I merged, made master 5, the 5 branch. And I have a bunch of gyros in there to remove stuff like Zazzle and stuff we don't need, and deprecated classes. I'm happy to keep my jar has always, with tests and demos, has always been around 2 megabytes, 2.1 megabytes. Now I'm happy to actually make it even smaller, 1.8 megabytes or whatever. I don't believe in having a huge transitive dependency tree, which pulls in the internet, but I actually have no dependencies. JGroups has no dependencies, and so it's very small and very very easy to change to new technologies like Quarkus. It took me 45 minutes to port JGroups to Quarkus, to make it Quarkus compliant, so I could actually generate Quarkus native image. And I believe in that. Keep it simple and stupid.
Yeah, absolutely. So on that note, I think we have to stop. Otherwise, we would talk, 24 hours. And this is a little bit too long for a podcast. So the most important thing, so where people can find you on the internet, and if you're just still doing the trainings, do you have some trainings in the pipeline the next time?
Yes, I want to come up with a workshop again, one in Europe, one in the US. And the tentative date was April, but there's always stuff that has to be done before that, to-do lists and, emergencies. So I still hope to do it this year, maybe in the fall. But if you're interested, join the mailing list on jgroups.org, and I will announce it there.
Very good. And do you have a Twitter account?
No, I don't.
Blog?
I have a blog, yes. It's on Blogspot.
Blogspot, okay. So I will find it. Okay. So perfect.
Blogspot.com.
And what your workshops are about? Are it just JGroups with Quarkus a little bit now, or?
Yes, I will have to take that into account. So I'm thinking it was always about JGroups, the API, that was the simple part. Then what are the most important protocols that are used? How can you look at the system, a running system in production, for example? How can you change things or extract information from a running system? What I want to do in the new workshop that's based on 5 will be Quarkus, a Quarkus part, and the other part will be cloud. There will be a Kubernetes part. How do you run JGroups in Kubernetes, OpenShift? These are 2 major additions to the workshop. I'll probably remove some of the more theoretical stuff so that it stays the course. It used to be 5 days, now it's 4 days, and I hope to keep it at 4 days.
Okay, cool. So thank you. And I would like to re-invite you again and talk a little bit about Project Loom or JGroups more specifically this year, if you have time.
All right.
Okay, thank you.
You're welcome.